Hello, everyone. I'm Patrice Johnson with Applitools, and I would like to welcome you to today's session, The Future of AI-Based Test Automation with Adam Carmi. Adam Carmi is the co-founder and chief technology officer at Applitools. He's the inventor of visual testing and has more than 20 years of technological leadership and innovation experience. Prior to founding Applitools, Adam held management, research, and development positions at SafeEnd, IBM, Microsoft, and Intel. He holds both a bachelor's and master of science degrees in computer science from Technion and regularly talks about software testing at conferences around the world.
Hi, everyone, and welcome to this session about the future of AI-based end-to-end test automation. You know, it's hard to believe, but only less than a year ago, ChatGPT came into our lives and sparked an unprecedented wave of excitement about artificial intelligence and the huge potential that it has to enhance productivity across different roles and occupations, including software development and test automation. In this session, we are going to explore the huge impact that AI has on test automation, starting with the tools that exist today, the way you can use them to overcome challenges that we're experiencing day to day trying to automate our end-to-end tests. But we'll also talk about the new technologies, generative AI and large language models, and see how they will shape the next generation of test automation tools, and of course, the roles that testers will play in operating them. So in this session, I will be focusing on end-to-end testing, and I'll start by explaining what these are and why they are important. Then I'll spend some time talking about some of the things that I'm sure you are already somewhat familiar with, which is the challenges with automating end-to-end tests today using the traditional approach. And then we'll talk about how AI can be used today to overcome these challenges. In the last part of the session, we'll talk about the role that AI will play in the very near future in test automation. I'll show a few demonstrations, a few demos, and there will, of course, be time in the end to answer any questions that you may have. Okay, so what is end-to-end or UI-based test automation? It is a very common and widespread type of testing that attempts to verify the correctness of a system through its UI. Basically, we are providing input by simulating user interactions from the user interface of the end application. By simulating these interactions, they in turn trigger requests that go to the API of the server, run some backend code for that matter, some business logic that may read or write information from the database, computing a result, returning it to the end application. It then renders it on the UI, and our test will pick those results out from the UI and assert on them to make sure that they are as expected. So as the name implies, an end-to-end test exercises the complete system end-to-end. This type of testing is supported by dozens of tools and frameworks, including Selenium, Cypress, Playwright, WebDriver.io, Appium, XUI, Espresso, and many, many others that I'm sure you are familiar with. Now, end-to-end testing is critically important and must not be skipped, because even if every component in our system works perfectly on its own, if they're not integrated correctly, we might end up with a system that is suboptimal that no one would really like to use. So you have to do end-to-end testing, and everyone does them. So what's wrong with the traditional approach to end-to-end test automation? In order to illustrate that, let's consider a very simple use case and how we would automate it using the traditional way. Let's assume we want to make sure that if a user tries to log in to our application without providing the username and password, he sees two error messages that indicate that those fields are required. And this is how we would automate such a test with Cypress, but it would look just about the same in any other test automation framework and programming language. Basically, in line number 3, we are navigating to the login page, and in line 5 and 6, we are locating the login button based on its attributes, and then click it. And then in lines 8 to 17, we have a bunch of assertion code that basically scans through the view hierarchy, the DOM of the application, searching for error elements, finding them, making sure that there are two of them and that they have the correct text. So although we have been writing tests like this for a few decades now, it doesn't mean that it's the optimal way to go. And basically, there are two things that are not so good about this example. The first one is that we need a tester with developer skills to relatively write a lot of code to test something very simple. The second thing is that this test code is very much intimately tied with the way that the application is currently implemented. And this means that when we will change the UI, whether because a front-end developer decides to refactor part of it, or because there's a requirement to add a new feature to the UI or change it in some way, we will change the implementation, and this can cause our test to break and crash. And when that happens, the same developers that are responsible for keeping up with the changes in the application and adding tests need to stop what they're doing and start triaging the problem. And the way to do it is by reading log files. And those developers are the only ones that can read those log files because they are the ones that are writing them. And using those log files, they need to start figuring out if there's a problem in the CI system, in the build, in the network, some testing infrastructure, or maybe it's a specific problem. Maybe it's really a bug in the application or a specific problem in the test. Then we need to find the owner of the test that failed and needs to go into the code, remind himself what he's done, figure out how to fix it, and then rerun the test. Hopefully it will work this time and provide the coverage that it's intended to do so. What we see across the board, and we are in touch with thousands of teams, from small startups to the world's leading brands, is that mature test automation teams end up spending anywhere between 40 to 70% of their time just dealing with analyzing failed test results and fixing broken tests. And when they get to this point, there's just not enough time to keep up with the changes in the application. You just don't have enough time to author more tests, and the more tests you author, the more maintenance overhead you have. So at that point, the value that you're getting from your investment in automation starts to diminish, because you have this gap in coverage that constantly grows. And what do you do with that gap? Either you test manually or you don't test at all, which means you're taking a very big risk on your quality. But in any case, test automation no longer solves that problem for you. The sad problem is that even the tests that you do have in place give you very limited coverage. So let's assume that a developer on the team decides to do a change on another part of the application, changes the CSS to accomplish it, and accidentally affects our login page. You can see that the sign-in page now, sign-in button now is shorter, it's green, the text is not white, and it's not capitalized, etc. We would categorize this issue as a visual bug. Why visual bug? Because the button is still there, it is still functioning. If you're clicking it, it will still attempt to log in. However, it doesn't look the way it's supposed to. Now, for some companies, this would be a critical issue. For others, it won't be such a big deal. But in any case, it is something that the test that we now have in place that deals with this exact flow, this test will not fail. It will not capture that bug for us, although we are just dealing with this area of the application. Now, we might argue that the test is not intended to find this bug, but what would happen if the same CSS change would actually cause the color of the error message to be white? Okay, it means now that we have white error messages on a white background, and that means that the end user doesn't see the error messages. Now, this is clearly a functional bug now, not a visual one, because the functionality that we want to test, that the user can see those error messages, no longer works. However, the test that we have just written to capture that issue will still pass. Why? Because there are still two error elements on the DOM, and they still have the correct text, just don't have the correct color. And we can think of 50 different ways, unexpected ways in which this functionality can be completely broken, and our functional test, the test that we wrote in Cypress, will still pass and not let us know that that happened. So the sad reality is that we need to write thousands of tests to cover a modern application using the traditional approach. These tests actually don't give us so much coverage. They require a huge amount of effort to maintain, and they require very skilled testers with developer skills to perform this maintenance. So how can AI assist with succeeding with end-to-end test automation today? Basically, there are two different ways that have proven to be extremely effective over the last years. The first one is that you replace the traditional assertions in your test with visual validations. The second one is that you stabilize your builds with self-healing locators. So I will go into details about both of these, and I'll use Applitools products to demonstrate it. So how do you replace assertions with visual checkpoint using Applitools Eyes, which is our own product? Basically, we provide you with an SDK that you can use to extend your existing tests with those visual checkpoints or visual assertions. We support any programming language, all the major test automation platforms, and basically any type of application that you're testing, whether it's web or mobile. In this case, you can see an example of the Cypress SDK that we use to replace the traditional assertions in our login test with an eyes check window command that is provided by that SDK. And basically, this is our visual checkpoint. The way that it works is that when this visual checkpoint executes, it actually grabs a screenshot, a full-page screenshot of the application under test, and compares it with the baseline image that defines how the application is expected to look like at this point in the test. If there are no differences that are visible to the human eye, the test will just continue to run and complete successfully. If, on the other hand, there are differences in the way the application looks like right now than how it's supposed to look like, this line of code will fail, throwing an exception just like any other assertion would. But the error message will also contain a link leading to our dashboard, to the Applitools dashboard, where you can clearly see the baseline image on the left-hand side, the checkpoint image on the right-hand side, and the differences highlighted in pink. As you can see here, the forgot password link was removed. Now, two things that are worth highlighting at this point. First of all, you can see that this single line of code actually captured the entire page. And it includes within it hundreds of elements that are on that page, including all the properties that affect the way that this page is seen by your end users. The second thing that you can appreciate is that everyone on the team that knows the product can understand these test results. He can see what the product was supposed to be like, what it's looked like, how it looks like right now, and if he knows what was supposed to be developed during the sprint, or what was just pushed as part of the code changes, you can realize if this is a bug or a feature. Okay, you don't need to be a developer in order to do that, or need the ability to read log files. Now, it doesn't just come down to understanding the test results easily. You can actually, everyone on the team can maintain the test themselves, because if this is an expected change, we intentionally remove that link. All we need to do is click an accept button, and this will take the checkpoint image and save it as a baseline image for subsequent test runs. If, on the other hand, this is a bug, it's an unintentional change, then all we need to do is reject the image and report a bug directly from within the test results. We can then collaborate and chat with team members on the bug itself, or export it to Jira or another bug tracking tool. Visual checkpoints have many advantages over the traditional approach. First of all, it allows us to extend our existing tests. We don't need to throw it all away and start from scratch. And by replacing the traditional assertion with visual assertion, you can reduce the amount of test code by 80%. 80% is a staggering number. It means 80% less code to write when you're authoring a new test, but more importantly, it's 80% less code to maintain for the entire lifetime of the test. Each of these visual checkpoints gives you complete visual and functional coverage for that page. It replaces hundreds of lines of test code that you would otherwise have to write in each step of your test, which of course you never do because you cannot, you don't have the time to write it or maintain it subsequently. But more than that, this line of code works seamlessly across any device or browser that you would like to test your application on without any changes. Because we compare the entire page at once and we highlight any difference that you will see, that your end user will see, it means that you can catch unexpected effects, unlike the traditional approach where there is only a specific type of failure that your test will highlight on. The only other alternative to catching unexpected defects is by doing exploratory manual testing today, but here you can get it out of your automation as well. This line of code is completely independent of the way that the UI is implemented, meaning that you will never need a developer to go back to the test code and fix it. And when the UI changes, instead of code breaking, you just need to go to the dashboard and either accept or reject the change using buttons, which is again something that everyone in the team can do. Another important advantage of using visual validations is the fact that you can actually execute your tests across different devices and browsers in orders of magnitude faster, more securely, and more stable than you can with any other approach. And this is extremely important, especially for teams that shift left and want to provide very fast and stable feedback to developers within minutes. The reason this can happen is because the mechanisms that use to render the pages and get those screenshots in order to validate them operate in a very different way than the traditional device and browser grids. Basically, instead of running each test multiple times on each and every device to get the coverage, you can run the test just once on any device, on any browser. You can run it locally on a dev machine or on a build machine or with a third-party device provider. And from that run, there is a technology that allows us to give you the coverage on all the different devices and browsers, and here's how it works. Basically, when the SDK executes the check window command, the visual validation, what it does is that it grabs from the browser where the test is running, it grabs all the resources, the DOM snapshot, CSS, fonts, images, everything that the browser needs to render the page. It then uploads this information to our own device and browser grid, along with the list of devices and browsers you want to test your application on. What the grid does is then it spins up those devices and browsers within seconds, serve the same resources to them, and in turn, they render the exact same UI that you would have gotten at this point of the test as if the test was running there, although it is not running there. Once all the UIs, the different UIs are rendered, we take screenshots of all of them and validate them using Visual AI, as I explained before. So the end result is that you can run each test just once, and at the same speed and stability and security of a single run, you get the coverage for as many combinations of device, browsers, operating systems, etc. So it's a fantastic ability that can get you to run entire test suites within minutes that would otherwise take hours to run. So let's see this in action. And basically, we will use Cypress and the Applitools Cypress SDK and the Ultrafast grid to execute the test and get the coverage. So first of all, let's see what is the flow that we will do during the test. What we will do is that we will head to wikipedia.org. And when we get there, we will search for the functional testing article. You just type the text and click the search button. That's that. That's not the article. So, okay. So it looks like Wikipedia is temporarily unavailable. They are not considering my demo, apparently. So in general, if we would have gotten to this page, we would like to validate it on 15 different devices and browsers. Now I'll run the demo anyway. Let's see if on this run, on the code itself, when I run the code itself, it will work. The test code itself is super simple, like I promised, 80% less code. All we do is visit wikipedia.org with Cypress, finding the search box and typing functional testing, then clicking the search button. And once we've done that, assuming that we got to the functional testing page and Wikipedia is not crashed anymore, we will do a check window command. And this will basically test this window for us using Visual AI. Now, if I run this few lines of code locally, I will just have one Cypress test running locally. In order to get the coverage on 15 different devices and browsers, all I need to do is just provide a configuration file that lists those devices and browsers that I want to test on. I don't need to do any further changes to my test infrastructure or framework or do anything with processes and distribution and concurrency and multi-threading. It's just a simple configuration. So let's run this test and see what we get. Hopefully this time it will work with Wikipedia. Let's rerun it. So we see Cypress loading wikipedia.org, going to the functional testing page. Yes, we got it. So we are on that page now. And first of all, you can see that there is just one run. This is a local run of Cypress on my laptop, nothing special about it. What's happening now is that the SDK is pulling down all those resources that I explained before, uploading them to the Ultrafast grid, along with the list of 15 devices and browsers that was listed in the test. And the grid is spinning up those devices and browsers, serving those resources to them, rendering those browsers, rendering the page. We're taking the screenshots and comparing them using Visual AI, using the visual validation, and producing the test results. So everything is done. All in all, the whole process, a test with 15 different devices and browsers took 41 seconds, for almost 42 seconds on the Cypress side, which is pretty fast. And if we head back to our dashboard, we can see that in a refresh, we can see that we have a new test suite, which is passing. It has 15 tests in total. The whole thing on the Applitools side took 20 seconds. That's it, 20 seconds from the start of the first test to the end. That's very, very fast. You can see here the different devices, browsers, operating systems. And if we switch to the gallery view, you can see thumbnails of that functional testing page, either on a desktop browser or on a mobile form factor. You can see how different it looks. And zooming in on any one of them reveals the amount of detail that is covered. This is a big page that spans below the viewport. There are hundreds of elements over here. Everything is compared between a baseline and the checkpoint image. They are matching, but anything that would change on that page, you will know about it. So the amount of coverage that you're getting is huge. So again, just to recap, a lot of coverage, everyone on the team can understand it very easily, and super fast execution across different devices and browsers, 20 seconds. Now, I'm running this demo quite frequently, and I often stumble upon all kinds of nice differences in Wikipedia because of that. And some time ago, I stumbled upon this nice difference over here. You can see this pink dot that appears across all these different renderings. And what you can see is that Wikipedia at some point changed the icon of their hyperlink. Okay, I can just toggle between the two so it will be easier to see. You can see it over here. Okay, so they changed it. I doubt that their own quality team knew about that it happened, but I found out because I'm using this technology to test it. So again, just to show the level of coverage, this could have been the wrong icon or an unintentional change and no one would notice. With this technology, you miss nothing. Now, the last thing I want to show you before we move on is another way in which AI can help us with test automation. As you can imagine, a change of an icon like that would span all the different devices and browsers, as it does, and it would also cover other pages, other articles. It would appear everywhere. And if I have to go and look at each one and accept it, it could take a long time and be a bit overwhelming in terms of maintenance. So here what we have is what is called automated test maintenance to our aid. Basically, no matter where I accept this change, let's say here, as soon as I provide this feedback that I approve it, automated maintenance starts looking at all my other test results, and if they have exactly the same change as far as the human eye can see, it is automatically getting accepted. So just by approving it once, I'm done maintaining this test suite, and I don't need to do it again and again and again. And there are plenty of features where AI is used to augment you as a tester, like a few team members that are sitting behind your back and just waiting for your subjective feedback that only you as a human being can provide. And once you provide it, they immediately run along and apply it everywhere else. Okay, and this allows teams to scale, and even in our case, run millions of tests every day without increasing the amount of test maintenance overhead.
Adam?
Yeah.
Hi, sorry, I'm going to jump in real quick. We actually have a ton of really great questions for you. So I'd like to take a moment just to look at some of those questions before you go into your next portion of your presentation, if you don't mind.
Okay.
All right.
Yeah.
So let's see here. All right, let me jump in. For visual testing approach, are approvals tracked in different feature branches, and do they automatically get updated post-merge to protected branches?
Yes, of course. So I will attest to our own tool. So it actually has a complete branching system built into it. So we have branches for baselines, just like you have branches for code. Every time you accept a change, it happens in its own branch. There's complete traceability of who accepted it and when did it happen. And when you are merging branches in code, we automatically merge the branches on the baseline side, on the Applitools side. And we have very comprehensive integrations with source control management tools like GitLab, GitHub, Bitbucket, and others that basically make all this process seamless. So as you push code as part of your pull request, you see the status of your visual test, and if any differences were detected, by a single click, you jump to the corresponding test results for the pull request on eyes. If you accept all differences, automatically your pull request becomes green. And when you merge the pull request within GitHub, it automatically triggers the merge on the Applitools side. So you're just working with Git or the other source control management system that you're working with in a supernatural way, and everything is dealt with by the integration itself.
Okay, fantastic. All right, let's see. We have quite a few. Just a reminder for folks, please, if you have questions for Adam, please post them in the Q&A tab versus the chat. We're trying to move them over, but at the same time, it'd be really helpful if you post them there so that way we can just push them all at once. Okay, so here's another one from Dennis. Does the run once and validate across multiple browsers also apply to native mobile apps or just web apps?
So this technology applies today only for web applications, but you can render on devices. So there's no problem running your web application on a desktop browser, doesn't matter which one, and get the coverage on mobile. Okay, and if you have like a mobile web application as well. But Applitools does support testing on mobile, on native mobile. That's not a problem at all. We just don't support it with the grid itself by providing our own devices for coverage. So you can test mobile application, native mobile application on iOS and Android. It doesn't matter which technology you're using to develop it. We support all of them. You can run tests locally on a simulator, on a real device, on a remote device farm. No matter how you want to do it, we support it and can test it.
Okay. All right. And I'm just going to drop.
For the sake of time, because we really have a lot more to show, I suggested we continue, and I'll be happy to address some of these questions later.
All right. Sounds good.
Awesome. Okay, so now moving on to a different approach, stabilizing builds with self-healing locators. Again, this can work in tandem with visual validations, but it's, on the other hand, it can work just on its own. The two are completely independent. So, in every test, in every step of every test that we write, we interact with some element in the UI. Right? We find elements in order to click them or type text into them, or we find elements in order to grab their properties and assert on them. Now, on every page, we have hundreds of elements. So in each step, we need a way to find the specific element we want to work with. In order to do that, we use element locators, which are forms of queries that allow us to pinpoint the element we want to work with. And as we mentioned before, a major problem with element locators is that they are tied to the way that the application is implemented, and because of that, in many cases, when the UI changes, not because of bugs, just because we are updating it, it causes our element locators to break and our test to crash. Now, for most teams, test crashing because of elements locator breaking is the primary cause for the delayed test feedback from the test and for the high test maintenance overhead, where team members need to spend time going back to test and fixing the broken locators following the UI changes. Now, self-healing that I mentioned, for those of you who are not familiar with it, actually applies artificial intelligence to be able to find an element in real time as the test is running, even if its locator is broken. Now, the way that it does that is not magic. It is basically using information that was learned about that element from previous successful runs. So, how does this self-healing work? I'll describe how it works on our products. We have an execution cloud that serves browsers for you to run your open source tests on. It does provide self-healing out of the box. So if you run your test on our infrastructure, your tests get self-healing automatically without you having to change anything in your test. How does it work? So basically, when you run your test on our framework and you're trying to find an element, every time you do that, we use the locator that you provide to find the element. If we find the element, instead of just returning it to your test so it can perform the action on it, we actually we capture hundreds of data points about it. So all the attributes of the element, the location in the hierarchy, information about neighbor elements and parent elements and all of that. And we take all this information and store it in our database using the locator that you use to find the element as the key. And then we return the element to your test. So every time you run the test and we manage to find the element using the locator, we always learn everything about it and keep it for the future. Now the day comes and the UI changed in a way that would break your element. Now that when you're running the test, we take your locator and try to find the element just as always, but we fail to do it. Now, instead of returning the error to your test, which caused it to crash with a no such element exception, which I'm sure you're familiar with, we take an extra step, the self-healing step. And what we do is that we take the locator that no longer works, and we go to our database and we try to find information about that element that we found using this locator in the past. If there is information, we actually use it along with our proprietary AI algorithms to find the element on the screen in real time. If we're able to find it, basically simulating the work that the developer will do to fix the test, if we are able to do it, we relearn everything about it, update the database entry with that same broken locator, and then return the element to your test. So despite the fact that the locator is broken, your test still gets the correct element and it proceeds to execute. So heal that test, we will show the broken locator that you used, and we even show you an alternative locator that indicates the element that we recovered, and you can also use that locator to fix your tests. Although we don't recommend you to do it because there's no point in doing it. You can keep using that old locator forever, and we'll keep finding it for you, even if the application, if the UI changes again and again and again, because every time we find the element, we relearn everything about it. So This technique is extremely robust. Our
I'm
self-healing
sorry,
mechanism can
Adam.
find an element even if simultaneously multiple of its properties change, the text changes, the position of the element changes in the DOM, its size or location changes. As I mentioned before, the algorithm itself is extremely adaptive. So every time you find an element, we relearn everything about it. So it's easy for us to find it in subsequent test runs and even accommodate future additional incremental changes that will occur.
I'm sorry, Adam. I'm
Self-healing,
going to hop
yes,
in for just a second. I'm sorry, your connection is not quite stable right now. So would you mind turning off your video?
I will do it. Apologize
Awesome.
for that. Should I go back?
Thank you. Sure, if you'd
Should
like
I
to go
go
back over
back
that
and
slide.
repeat something, or?
Um, I think if you go back over that slide, we should be in a good spot right there.
Okay, I blocked the video. Should I go back? Sorry,
Yes,
Patrice?
you can yes. If you want to just go back over that part, yes, it just broke up a few times.
Yeah,
Just one
okay.
slide. Yeah.
So, yeah, okay. So self-healing has huge benefits for any team that is doing test automation. First of all, it means that your test won't crash and won't delay feedback to developers. It means that you can release faster and you avoid the time spent when developers don't get the feedback, context switch to a different task, start working on it, and then when you manage to fix the test, go back and fix the bugs. And therefore, you can increase the velocity of the team. Also, it prevents the need for you to go back and fix broken locators following UI changes. And these two things together can save hours every day for team members that are involved with test automation that they would normally spend reviewing failed test results and fixing broken locators for following UI changes. It can actually double the efficiency of team members that are heavily into test automation. Besides avoiding test failures and test maintenance following UI changes, self-healing is very useful in the following scenarios. In some cases, you have team members that are more junior and have poor locator authoring skills. Normally, this would result with tests that are more flaky and require more maintenance. Self-healing solves that because it's enough for the test to succeed once. From that moment on, self-healing takes care of locating elements, even if the initial locator was bad. It's very useful to allow testing applications with weak locators. That sometimes happens when one team of developers is just building the application, and then it hands it off to a separate group that needs to deal with testing. And there is a disconnect between the teams. So the developer built the application not being mindful of testing, of its testability, and then it creates a very hard time for the testers to be able to build stable automation on top of it. Self-healing solves that because it's enough for a test to work once, and then it doesn't need a strong locator. It can deal with all the different ways to identify the element to create its own AI-based powerful locator. And last but not least, it allows you to test internal applications with dynamically generated UI, like Salesforce and SAP applications. If you ever try to automate something like that with Selenium, you know that it doesn't work very well. With self-healing, you can definitely accomplish that. So let's see self-healing in action by using the Applitools Execution Cloud. So what we will do in this demo is that we will use this demo application and we will perform a simple login. We will basically head to this application, type in a username and a password, and click the sign in button. Once we click it, we get to this dashboard, and to make sure that we got here, we will validate this text, your nearest branch, on the title. A very, very simple test, and we will implement it with plain Selenium in JavaScript. So in order to click the sign-in page, we have to find it first, of course. And the way that we'll do it is that we will use its ID. The ID is login. We will find this button with the login ID, and then we will click it. Now, in order to show self-healing in action, we will simulate a UI change before we go through this login sequence. We will use JavaScript to find the sign-in button and to change its ID to be something else. We'll change it to blah blah ID. Then we will find the button again with the new blah blah ID and change the text to be blah blah. Okay, then we will attempt the original code to sign in, and of course, when we will try to find the button with the login ID, we will fail. If there is no self-healing, the test will crash. If there is self-healing, it will be able to find the sign-in button for us anyway, despite the fact that there is no longer an element with a login ID, and it will be able to get the test to complete and pass. So let's look at the test code that we are using to run the demo. So it's just a plain Selenium test with the JavaScript language bindings that is very simple. It doesn't do any visual validations. It's just plain old Selenium. So what we do here is that first we navigate to the login application. Then we simulate the change to the UI. As I explained before, we execute some JavaScript that basically finds the element with the login ID and changes the ID to be blah blah ID. Then we find the element with the blah blah ID and change the text to be blah blah. Now we go through the original login flow. We put in the username, the password, and then we look for the button with the login ID, which no longer exists, and we try to click it. Okay, without self-healing, this line would crash with the no such element exception. If we have self-healing, we'll be able to continue, and then we will get to the dashboard and validate the text over here that starts with your Linux pledge. Now, our WebDriver test, a Selenium test, needs a WebDriver. This WebDriver is initialized before the test run using the getDriver method. The getDriver method simply returns a normal remote WebDriver that is built with a builder. It just points to the ICE execution cloud and has its own capabilities. The important capability is use self-healing. And we'll start by setting it to false so that the test will be executing on the Applitools cloud using a browser on the Applitools cloud. However, self-healing will be disabled. So let's run the test and see what we get. So Mocha is starting. Sometimes it takes some time for the one to kick off on my machine. Okay, we're getting a browser. The test started. And now we go to the demo application. We are modifying the login button, trying to log in and crashing. And we can see that we have a no such element error, that we are unable to locate the element with the login ID. Makes sense. This is what we are used to live with. However, if I turn on self-healing, this is done at the infrastructure level. I'm not changing a line of code in my test. Okay, and I rerun that test. This time, I'm getting the remote browser, going to the application, modifying the login button, performing the login successfully, getting to the last step, and the test is passing. Okay, self-healing actually prevented this test from crashing. If I head back to the dashboard and I refresh, I can see that we have two new tests here. The first one is the failure of the test that we had when it crashed. And the second one is the successful run. Now, next to it, there is this magic wand over also here next to the test suite that indicates that we had a self-healing event for this test. If we can see the details, we can see that we try to access an element using the login ID. We heal the test, and here's the element that we actually managed to find instead, or the new implementation of the element, and there is a suggested locator for it, which is the href of the element. So we can take this and use it to fix the test, although we don't need to because we can still continue and use the old locator. The test will run fine, and there's no need to spend development time on going back and fixing the test. We will continue to find it using that locator, even if more changes will happen to this element in the future. Now, naturally, like every execution cloud, you can see recordings of the remote run and network logs and console log and all that stuff, but that's not related to the topic of this presentation. Okay, so to summarize, using AI today, we can actually overcome a lot of the challenges that we experience with automating end-to-end tests. We can drastically increase test coverage. We can reduce the amount of test code we need to author and maintain. We can eliminate repetitive maintenance work with features like automated maintenance. We lower the required skill set to maintain automated tests so that everyone on the team, even if they don't have coding skills, can understand test results and participate with maintaining the automated tests when the UI changes. We can improve the build stability. We can shorten the feedback loop to developers and thus increase team velocity. So it is very much possible to succeed at very large scale with end-to-end test automation by incorporating tools that rely on AI to solve these core challenges and problems. So now that we understand how existing tools can help us, let's talk about the role that AI will play in the future. And when we're talking about the future of test automation or the future tools or next generation of tools, we are talking about autonomous testing platforms. This is what basically everyone is trying to get to. This is the equivalent of self-driving vehicles in the world of test automation. So an autonomous testing tool will basically, its goal is to create an entire test suite for your application out of the box. It will be able to automatically explore your application and reach all the interesting states so it can test them. It will automatically add validations, either by reporting regressions from previous runs or changes in behavior, either by reporting discrepancies between the performance of your application versus standard benchmarks in the industry, or it will just attempt to run some generic test flows like login flows, sign-up flows, or more specific flows like add-to-cart flows for retail applications and similarly for other types of applications. Now, it's important to understand that an autonomous testing platform doesn't need to provide you 100% coverage to be valuable. Today, teams spend huge amount of time, effort, and money on end-to-end test automation, and maybe they get to 10-20% coverage if they are doing very well. If a tool like that can get you to 70 or 80% coverage without you having to do anything, that's a huge value for you and your team. Now, naturally, the more generic your application is, the better the tool will perform on it, right? Because it would look more similar to what it's trying to work on. But there will always be gaps, and these tools will provide you with the means to fill up those gaps. So either it will allow you to do some customization and retraining of some models to fit your application better. Maybe it will require you to write some test code. Maybe it will you will need to record interactions with the UI like you do with Verco playback tools today, or using the latest and greatest technologies, just instruct the AI what to do in plain English, just unstructured plain English, saying something like click the link below the blue button at the bottom of the page. Now, how would you evaluate if an autonomous testing tool fits your needs? So first of all, and the most important thing is to understand what is the coverage that you're getting out of it. I mean, I rarely found someone who can say, yeah, I just trust this AI to test it for me and I'm not going to test it myself. No one does that. It's very important to understand deterministically what you're going to get. So you need to make sure that the application actually really discovers all the important states in your application. You need to make sure how does it validate that state? Is it just checking some properties, textual properties? It is testing visual aspects as well. Does it cover different execution environments, and etc.? But another important thing is to remember that your application is not static. It is changing all the time. You're adding features. It might be that today the tool is providing you with a lot of coverage, Now you have a new sprint, you made some changes, and all of a sudden this coverage dropped by 50% because the AI is stuck there and cannot reach other parts of the application. It's also important to see how the application can report cases like that to you and clearly indicate when the coverage changed, whether it increased or dropped, so you can adjust your testing beside it in an effective way, right? So you don't have gaps in your testing. It's also important to look at what is going to be the ongoing maintenance overhead. How well will the tool adapt to application changes? I've seen some tools that claim to be autonomous, and mostly what they do is that they dump that first test suite for you, writing a lot of tests for you, but then they leave it to you to customize that test, and they cannot really keep them up to date as the application changes, which means that they only take you the first step, but you still have to do the heavy lifting moving forward. Another aspect is how well does the tool facilitate large-scale test maintenance. Using a tool like that will get you up and running right from the start with a very big test suite. It's not like starting a new project where you're adding the first and second and third test. You will start with many, many tests. So this means a lot of test maintenance, a lot of test results to review, and the question becomes is how does the tool help you accommodate that at large scale? You need to see what skills you have and what in the team and what skills that the tool requires to have in order to operate it. Can any tester just operate it, or do you need some coding skills, ability to deal with element locators, maybe some machine learning skills to retrain models? Do you need DevOps skills to be able to set up a CI and maintain it and deal with builds and deal with execution environments and all of that? And last but not least, as I mentioned, no autonomous tool will give you the 100% coverage, and it also matters what means are available to you to fill the gaps that it cannot do by itself. Now, at Applitools, of course, we have been building our own autonomous testing product that I'm very happy to say that is starting the early access program next week and will be available for everyone at the end of the year. I'm not going to show it to you today. I'm going to leave this single slide as a teaser. And if you're interested to see it in action, I will be showcasing it in our Future of Testing event on November 7th. So you're all welcome to join. What I can tell you is that this tool is going to be able to create an entire test suite for any website just by putting the URL of that website. Just by doing that, you will get it all. And when it comes to filling gaps, you will be able to do that in plain English, just like you're used to see with ChatGPT today. So what I can show you is this technology in action because it is super, super cool and exciting. So we call it a prompt-based testing. And I will show it with an internal tool that we have at Applitools that we use to develop this technology. Basically, we have on the left-hand side here a prompt where I can just type plain English, and it controls this browser here on the right-hand side that now leads to Wikipedia. Let's see if Wikipedia is still up and running. If not, we'll see what we do. But let's control Wikipedia using just plain English. Let's start by doing something simple. Let's click the English link over here. So we can just say, click English. No need for element locators, no need for code. We can go back. Let's click the Japanese link over here. I don't have Japanese font, but I can say, click the link to the right of English. And here we go. We got to the Japanese page. We can go back. Let's try to get to this Francais link. It's more complex, but we have the full power of the English language. So we can say, click the second link below the link to the right of English. Here we go. We are on Francais page. Isn't this super cool? Let's go back. Let's try to search Wikipedia, and we can say, I hope it will work this time and it won't crash. So let's type functional testing in the search box and hit enter. And here we go, hitting enter. No, this page is still broken. So Let's look at a recording of this video. Wikipedia will not mess things up for us. So basically everything we've done so far, we can type functional testing. And here we go on the functional testing page. We can try to click that show link to the right of tools. This would be difficult with code. We have to find the surrounding elements using a locator and enumerate the lines there. And here we were successful, and the show changed to hide. It expanded, and now we are clicking show above hide. So very, very easy and intuitive to work with. We have a bunch of edit links here. Let's click the one next to 6 steps. So we can say click edit near 6 steps. And now we are editing the functional testing section. We got rid of that pop-up. We can now interact with the search icon. So we can say, click the search icon, type ChatGPT and hit enter. So we can actually put in like complex instructions, and prompt-based testing can execute it as well. And here we got to the ChatGPT page. So isn't this super awesome and exciting? I mean, I'm super excited about it. Now, as you saw, prompt-based testing takes like English descriptions of user interface instructions and is capable of performing them without having someone to translate them into code or implement certain keywords, and I can use whatever form of valid English language to guide the tests. Even those test cases that you have today that may be used for manual testing or as descriptions of what should be implemented in automation, you can just execute these. But what we want to get to is a point where we can describe tests in the language of the functionality of our product. For example, if I'm going to Amazon, I want to say just order the Dune book and not describe all the steps that are required to do that. So this is where large language models excel. Basically, you can point these models to any descriptions of these high-level operations, let's say your online user documentation, if you have that, or something that you just provide as a tester to explain those higher order commands, and it will basically learn them and be able to execute them for you. So just to demonstrate it, let's take ChatGPT, which scanned the entire internet, and because of that, it also scans the user documentation for ordering a book on Amazon. So it will be able to actually give us the step-by-step instructions for doing that. Okay, so that I can basically say in a test, just order the Dune book. Now, you can see the text here. Give me step-by-step instruction for ordering Dune book in Amazon.com for Kindle using my default payment details, and then some instructions of how I want this reply formatted so I don't get a big article with a lot of useless information. So I have the same text here in this Notepad app. I'll copy it, and we'll head back to ChatGPT. Okay, and we'll just paste this here and run it and see what we get. So you can see that ChatGPT, after reading the user manual for ordering books on Amazon, can tell me exactly what are the steps that are needed to do it. Click on the search bar at the top of the page, type Dune book into the search bar. Exactly the type of things that I've shown you that prompt-based testing can do. So this is exactly how we can abstract, get rid of functions and all those programming stuff and just allow us to describe very robust tests in plain English. This is pretty cool, and this is included in Autonomous coming out next year. So to conclude the session, let's talk about the roles the testers will play in the future. Now, a lot of people that I spoke with, and also a lot of in the media, is trying to frighten us with prophecies that all these technologies is going to put us out of work. But in fact, I believe that the exact opposite is going to happen. So basically, if I look historically on all these technological inventions, in many cases, they actually lowered the bar and allowed a lot of more people to participate in doing those jobs. And if we look at tools like Copilot and ChatGPT, they actually lower the bar for people to become developers. Now, imagine that AI is not 100% accurate, it never is. And that means that any code that it generates is going to be less accurate. Now you're going to have less skilled developers that are in charge of generating code because they have AI to assist them, and they will be the ones that are responsible for looking at this code and approving it. And we'll have much more code generated that needs testing because AI will generate it much faster than people can, and there will be more people that will be able to operate it. So if I look at all of these things together, the role of the tester will become much more important than ever, because we will be the guarding gate of releasing crappy products that don't work, and there will be much more software to test. So of course, there will be tools like Autonomous that will allow us to basically do our job in a much more efficient way. Otherwise, we wouldn't stand a chance dealing with all this complexity. However, definitely the role of a human tester will be there, and again, will be much more important than ever. As testers, we will still be in charge of deciding on the testing strategy, deciding on which tools I need to work with, constantly guide and fine-tune the AI, making sure that it works well for our application as it evolves and changes. We will always be there to decide if a change is a bug or a feature. AI won't be able to do it in 100% accuracy, because even us as people don't always agree if something is a bug or feature. If I like something, doesn't mean that you like it. We definitely cannot trust AI to make this decision for us. And of course, because all those autonomous tools and AI will never be able to test everything for us, definitely not the human user experience, we will be needed there to test everything that the AI won't be able to do. So with this optimistic note, I conclude the session, and I'll be happy to answer any questions that you may have.
That was fantastic, Adam. Thank you so very much. We have a lot of questions to go through. Okay, so
I can imagine.
Yes, let me jump right in here. So, is there a way to exclude part of the page in visual validation?
Yes, definitely. So you can actually, so there are plenty of ways to do it. So first of all, you don't have to test the full page to begin with. You can indicate a region or an element in the page that you want to focus on. Even if it's scrollable, we can get the full page screenshot and just focus on it. But other than that, even if you take the full page screenshot, you can easily annotate the baseline by highlighting areas, annotating areas that should be ignored, that should be compared only by their layout. For example, if there should be text and you don't care what text is going to appear in a certain area, you can just tell the AI that this is what you need, and as long as there is text there, it will be validated. If it disappears completely or replaced with an image, then the test will fail. And you can do this type of things both through the UI without writing a line of code, just by drawing those regions on the baseline image, or you can do it using the SDK itself by indicating the elements that you want to ignore or that you want to compare in a less strict way.
Okay, awesome. All right, is that image comparison logic robust enough to cover different resolutions and scroll bars?
Yes, it does. The technology, we have been developing it for 10 years now. It is very mature, very robust. We have hundreds of the world's leading companies using it extensively. We have companies running millions of tests every day. Imagine that. So imagine the accuracy that is required to get to this point without any false positives that would drive you crazy. So it is very robust, and it deals with any type of page, dynamic pages, full pages, scroll bars on internal elements, all of that is taken care of.
Okay. All right. How about this one here? Can you please clarify, self-healing will increase the execution time if there is a big regression suite, default wait time, and custom wait along with if-else conditions?
Okay, so when we build, I can testify on our own solution, not other solutions. So we are doing a huge amount of optimizations to make sure that the impact would be as insignificant as possible. So basically, what is the overhead involved? So when you're finding an element, we need to find information about it that is already available and cached in the browser. And, oh, I see. Let me wait for connection to improve. Can you hear me okay?
Yes, we can hear you. If you can just repeat that last sentence that you provided right there.
Yes. Yeah. Okay. Yeah. So we did a lot of optimizations so that I will close the video. Sorry. I hope it will work better. So we did a lot of optimizations so that when we are finding an element, we very quickly gather the information on it and store in the database in a way that won't slow down the test. And the algorithm itself, when trying to find an element following a UI change, can take a little while, a few hundreds of milliseconds, but that only happens if we cannot find it immediately when we're starting to search for it. Remember that every time we find it, we relearn everything about it, so we know exactly how to find it quickly the next time. So all in all, in a test that would otherwise take 10 seconds, the overhead could be as minimal as a few tens of milliseconds or very few hundreds of milliseconds on a normal run. So in general, there shouldn't be a big impact.
Okay. As far as I understand, AI is involved in the image comparison step, correct? Anywhere else?
Yeah, so when we're talking about the existing tools that I mentioned, so we have, first of all, to get to do what we do requires a lot of techniques, from traditional rule-based algorithms to traditional machine learning models and also deep learning. All of that is integrated inside the image comparison part. AI is also incorporated into the automated test maintenance functionality that I've shown you, the ability to basically, and just so you understand, you need to be able to emulate the human vision in order to do this at scale without mistakes, without missing differences that shouldn't be missed, and without getting confused by rendering artifacts that happen when you're executing the test across different devices and browsers, when the browser updates, when there's an update to the graphics card, and a million other things that affect how the page gets rendered. So there is a lot of AI there. There is a lot of AI around automated test maintenance. So basically, when I accept a difference, I want to analyze in a very robust way how that difference appears in other pages of the application, other screen resolutions, other devices and browsers. AI is involved there as well. And when we're talking about self-filling, this model that allows us to find elements on the screen is also using AI techniques to accomplish that. So everything that I've shown you involves AI.
Okay, fantastic. All right, here's another one. Can this work seamlessly on different languages? So localization testing?
Yes, one of the main use cases for using visual validations, one of the reasons actually that put me on the path to start developing this technology, and at some point to found the Applitools together with my co-founders, were challenges with localization testing. So basically, there are two ways to work with it. The first one is that when you are developing a new language, you can actually compare the existing language with the new one by comparing the symmetries on the page, and this helps you find issues where text exceeds the boundaries of elements or pushes other parts that it shouldn't when you're replacing text strings which are longer or shorter in different languages. And once you stabilize that new language, you can actually create a unique baseline for it. And then the value here is that you can identify immediately any change that occurs on any specific language. And this is important because as testers, when we don't know the language, it's very difficult for us to identify differences. There could be a typo on the screen and we won't know about it because it won't stand out to us. Okay, but once we baseline each language, any difference, just like we saw with Wikipedia and the hyperlink, you will see it as a difference. And then when your automated test run and they detect those differences, you can just take the URL of that test result, send it to the language expert, and he can tell you if that's okay, or if that's an issue. Compare that with having to work with a language expert and go through the entire application manually for each release and go over and make sure that he sees everything and approves it, and he's only a human, so he's probably missing out a lot of defects on the way. So this is an extremely effective way to accomplish localization testing.
Awesome. Fantastic. Okay. There's so many questions. We're just going to go with one more question, but fear not, folks. If your question is not answered, we will forward the questions to our testing specialists so that way they can follow up with you, or feel free to reach out directly to us. You can also ping in the chat. I think there's some people in there as well. So this last question, self-healing. If we are using page object pattern or dynamically construct selectors, wouldn't we have to keep the selectors up to date, regardless of self-healing capabilities, since new selectors are going to require accuracy to pass first?
So I'm not sure exactly what do you mean that you dynamically construct selectors. I would expect that the selectors that you dynamically construct are at least valid once. If they are valid at least once, first of all, the test won't crash, and as long as you're using them, even if the UI changed in some way and you don't change the selector, it will still pass rather than crash. So again, I'm not sure how you can dynamically construct the selector in an accurate way for every UI change. But if you already do that and it never fails, then you don't need self-healing. If you do that and it does fail, then it will probably help you a lot.
All right, fantastic. Thank you so very much. Thank you, Adam. I want to thank everyone that joined us for this session. If you really did not get enough of this presentation, you want to learn more, as I know everyone really does, especially on that sneak peek of Autonomous, be sure to join us on November 7th, where Adam will be giving a keynote for our Future of Testing free virtual event. And the focus is going to be, again, on AI and automation. Thank you so much and have a great day.
Thank you, Patrice. Thank you, everyone. Thank you for joining. Bye-bye.